So today we're starting chapter 5. You might say, well, what happened to chapter 4? We don't do chapter 4 till the end of the year, so we just go from 3 to 5. So today we're starting section 5.1. It's all about graphing quadratic functions. We will also do this again tomorrow, so you have a couple days to learn to graph. Section 5.2 also takes 2 days, so we're really kind of slowing it down at the beginning of chapter 5. Hopefully diving into these and slow enough that you guys really understand it. So today we're going to start talking about parabolas. So here's the formal definition of parabolas. Parabolas are one of the conic sections. Conic sections are basically shapes you can get by taking a cone and slicing it in certain ways. We're really going to talk about conics a lot second semester. The only conic you get into first semester is parabolas. So here's a parabola. You can see if you take a cone and slice it with a plane, it forms this nice little U shape. That's a parabola. I would not worry too much about this formal definition. As long as you know that it's a U shape, we should be fine. Any questions on what a parabola is? All right, parabolas are actually kind of cool. You see them a lot just around town. Mostly anything that has to do with gravity, like water, rising and falling. That's a parabola. This is a ball bouncing, the path that a ball would travel as it's bouncing. Roller coasters have a lot of parabolas. Here's a nice little dolphin parabola shape. Can you guys think of any other parabolas? The arch, not a parabola. Everyone always says the arch is a parabola. This is actually called the catenary curve or hyperbolic cosine. You'll learn about it a lot if you take trig.
Can you go back to the definition of parabola?
Yeah, you want to see the definition of parabola? I actually don't know if I'd write this down. This isn't super important. This is just kind of the general background of parabolas. What? Yeah, as long as you know parabola is a U shape. We're going to do a lot of writing today, to be honest with you, so I would not write stuff that's not completely necessary. So if you don't get this down, not a huge deal. All right, so back to what's a parabola. Here are some parabolas. Not a parabola. Everyone thinks the St. Louis Arch is a parabola, but it is not. However, there are some big, cool parabolas. Here is me and my husband sitting in front of a parabola. Pretty neat. This is a picture without us in front of it. This is Rainbow Bridge National Monument in Utah. It is one of the only naturally occurring parabola structures. Pretty cool, yeah. So it was formed. There used to be like a creek down here flowing. It cut out this awesome parabola. We went last summer. We were on a boat with a bunch of people that didn't speak English to see this. We didn't know it was a parabola, but we pulled up and our tour guide was like, hey, did you guys know this is a parabola? Nobody cared, but we were like, oh my gosh, parabola. So we were very excited. Here's another one. People think this is a parabola. It's not. It's the same shape as the arch, but still pretty cool. So if you're ever in Utah, check these two things out, parabola, not parabola. Any questions?
What's the difference?
It's the shape. You'll see we have certain equations that define a parabola. So if you try to write the equation, this could be defined by the certain equation, this could not. It's mainly there's a lot of measurements. We'll get into it. A lot of parabolas, though, it depends on how quickly they widen. So see how this gets a lot wider, where these are a lot taller. So kind of cool. Just a little background on parabolas and not parabolas. Any questions? All right, here's actually the math, enough pictures. So we're going to look at 3 different types of equations that will form a parabola today. The first one's standard form. So standard form is the one you've probably seen most often in your Algebra 1 class. It's y equals ax squared plus bx plus c. So I would definitely write the equation down. Today we're going to focus mostly on graphing these. Tomorrow we'll work on different ways you could write the equation, but today I'm just going to give you the equation and you're going to graph it. Here are the steps to graphing a parabola when it's in standard form. I would write all this down, yes. That's why I told you not to waste your writing power on the previous definition, because we do have a lot of steps to write down today. So the first thing you want to do when you're graphing these, you want to find the vertex. So using that form, y equals ax squared plus bx plus c, you're going to take the opposite of b, divide it by 2 times a, That's the x value of your vertex. Plug it back in, that'll give you the y value of the vertex. Then you can determine which way the parabola opens. If A is positive, it opens up. If A is negative, it opens down. Similar to the absolute value equations we looked at, these will have an axis of symmetry. It's just through the x value of the vertex. Then we're going to make a t-chart, find a point, and then since it's symmetric, we can use that property to find another point. So it looks like a lot, but once you get going on these, they go pretty quickly. So definitely make sure you get all these steps down. These are actually not in your book. Usually the book is pretty good about providing you steps. These are not in the book. Any questions as you're writing this down? Any step that you're like, I don't really know what this means?
What is that?
The axis of symmetry, it's the line through the x value of the vertex that shows where the graph is symmetric. The equation is the same as the x value of the vertex, just x equals negative b over 2a. You're welcome. Other steps you're unsure of? I think most of you are done. Anyone need a little more time? Okay, a couple more seconds. You can definitely probably abbreviate the fourth and fifth step. The important part is probably 1, 2, and 3. Most important steps. All right, here's our first example. Again, the first thing you want to do is identify what form the equation's in. This is definitely in standard form. You can tell because we have an x squared term followed by an x term followed by a constant. So the first thing you want to do is figure out what a, b, and c are. What's a in this case? 1, yes. So I'm going to put a 1 there. I'm going to label it a. What's b? 2, good. And then what's c? 1, great. All right, so I have my a, b, and my c. How do I find the x value of my vertex? X equals? Negative b over 2a. Good, so that's going to be negative 2 over 2 times 1. Which is just negative 2 over 2, which is negative 1. Good, so the x value of my vertex is negative 1. To find the y value of the vertex, you just plug negative 1 back into the equation. So we have negative 1 squared plus 2 times negative 1 plus 1. Negative 1 squared, of course, gives us 1. 2 times negative 1 is negative 2 plus 1. So what's the y value of my vertex? 0. Good. So my vertex, I'm going to label it with a V, is at the point negative 1, 0. I'm going to go ahead and graph it. Now I'm going to label axis of symmetry as just AS. Where is the axis of symmetry? It's at x equals negative 1. Good. So this line, x equals negative 1, is the place where my graph will be symmetric. If you have a point on the left, you should have the exact same point on the right of that line. Questions in the back? Okay. What do I do next? Anyone remember from our steps? Yeah, I have to decide if it's going to open up or down. If A is positive, your graph should open up like a U. If A is negative, it should open down like an N or an upside down U. Anyone know which way this one's going to open? Up. Good, since A is positive. All right, now we can find our next point. So I'm going to make an XY chart. Now, here's where students get kind of confused, but I think this is actually one of the easiest steps. You just pick any point you want to the left or the right of your vertex, any x value. Anyone see an easy one? 0. So I'm going to plug 0 in for my x. When you plug 0 in, to find the y value, we'd have 0 squared plus 2 times 0 plus 1. So what's the y value? 1. Good. So I now have a point at 0, 1, and I can graph it. If you have a point at 0, 1, where else do you have a point? Yeah, negative 2, 1, because it's symmetric. Great. Let's pick one other point. You can't really tell, those are all kind of close. So let's pick another one. What do you want to plug in now? You can pick any number. Don't pick 0, we already did it. Don't pick negative 1. Don't pick negative 2. We already have those points. Anyone want to do another one? 1. Let's do 1. That's an easy one. So when I plug 1 in, I would have 1 squared plus 2 times 1 plus 1. So 1 plus 2 plus 1, 4. So now I graph 1, 4. And it's symmetric, so where would I have another point?
-3, -3, 4.
Yep, -3, 4. Great. Alright, I think that's enough points. So we are going to graph it. Remember, these are U's, they're not V's, so make a smooth curve. And put arrows on the end because they keep going. What are your questions on graphing a parabola when it's in standard form? Alright, here's our next example. So I'm going to start by labeling what A is, what B is, and what C is. C doesn't really come into play much here. You will use C a lot, however, in a couple weeks. I think about 2 weeks we'll really work with C. What do I do first? Yeah, x equals. We want to do negative b over 2a. So what's negative b in this case? 8, good. Over 2 times negative 2. It's going to be 8 over negative 4, which is going to be negative 2. How do I find the y value of the vertex? Plug it back in. Good. So y equals negative 2 times negative 2 squared minus 8 times negative 2 minus 5. Alright, if you have a calculator, you could just type that all in. I know that negative 2 squared is going to be positive 4. Positive 4 times negative 2 is negative 8. It's going to give me plus 16 minus 5. Which should give me positive 3. So my vertex is at negative 2, 3, and I know my axis of symmetry, whoops, this goes through the x value of the vertex. Any questions so far? Alright, is this going to open up or down? Down, good. A in this case is negative, so it's going to open down. Now let's do an XY chart. What do you guys want to plug in? You can plug in any x value except negative 2. Because when you plug in negative 2, you'll get positive 3. We already know that one. Negative 4?
Yeah.
Is there an easier one?
Yeah.
I always use 0. 0 is super easy. You could use negative 4. You could use negative 3. You could use negative 1. But I'm just going to use 0. It's the easiest one. How many? That's a good question. How many points am I going to make you graph? The minimum is definitely 3. I usually do 5. It kind of depends on how quickly you can see the shape. Like on the last one, we just had a cluster of 3 points. That's kind of hard to tell what the shape is. This one, though, I think if we graph 0 and then the point where it's symmetric, I think that will be enough. But let's double check. So when I replace all the x's with 0, that term's going to be 0. This term's going to be 0. Then we subtract 5. So we're going to get negative 5. So 0, negative 5. All the way down here. What would my next point be? If I have 0, negative 5, I also know what?
Oh, you know your point of symbol. 2, positive 2, up 3. 2, 3. Yeah.
Oh!
2, 3.
2, 3 would be if this was my point and this was my vertex. You got it the other way around. This is the vertex. This is the axis of symmetry. Here's the other point. So it's actually going to be symmetric right here. What is that point? -4, -5. Good. Now, here comes the question that we were just asked. Do I need more points? Do you think I need more points, or is 3 going to be enough? 3 is definitely enough here. If you go any further, you're going to be way off the graph. So just make it a smooth curve. No V shapes. And put arrows. Any questions on this? All right, here's number 3. All right, I'm going to start here by labeling A, B, and C. What's A? -1. Good. What's B? Good. What's C? 4. Great. So how am I going to do -b over 2a if I don't have a b? It's just 0. 0 over 2 times -1, which is just 0. So the x value of my vertex is 0. How do I find the y value? Plug it in. So -0 squared plus 4. That's just 0 plus 4, which is 4. So my vertex will be at the point 0, 4, which means my axis of symmetry is the line x equals 0. Great. All right, is this going to open up or down? Down. Good. A is -1, so it's going to open down. And we can start finding more points. Now, I said I always plug 0 in. Can I plug 0 in? No. Any other ideas? 1. Good. So when you plug 1 in, you'd get -1 squared plus 4. Now, students mess this up a lot. Is that -1 times -1, or is it 1 times 1, then you make it negative?
-1 times -1.
It's not in parentheses. If you were going to use parentheses here, just the 1 would be in parentheses because that's what we plugged in. All right, so be careful there. That's 1 times 1, then you make it negative. So it's -1 plus 4, which is 3. Good, so I am going to graph the point 1, 3. Ooh, I forgot to draw my axis of symmetry. Good, I also have the point -1, positive 3. Now, is that enough to really know the shape of this graph? Not really. So I'm going to plug in 2 as well. So when I plug in 2, I have negative, and then 2 squared plus 4. What's 2 squared?
0.
2 squared is 4, then you make it negative, then you add 4. Yep, so you get 0. So here's a point, and since it's symmetric, I also have -2, 0. I think that's definitely enough now. We can draw in our curve. Hopefully yours is a little better than mine. It's a little lopsided there in the middle. But you get the gist. Any questions? All right, I told you we were learning 3 forms today. Here's our second one. It's called vertex form. So y equals a times the quantity x minus h squared plus k. This form is really, really helpful because we don't have to do all that -b over 2a stuff to find the vertex. We already know the vertex. Whatever they're subtracting from x is our vertex. So it's the opposite of whatever's in here. And then you keep the sign of the k. This confuses a lot of students. When we are talking about graph transformations next week, we're actually going to explore a lot why it's the opposite of this, but this sign stays the same. So we will get more into this. Just for now, remember that it's the opposite, and then same sign. We also know the axis of symmetry just by looking at it. Again, it's through the x value of the vertex. And then once you know the vertex, you do it the exact same way as we were doing it previously. So I'll give you a second to write this one down. Any questions before we look at some examples in vertex form? So as you're looking at this, I can definitely tell right away that this is vertex form because I have the x value in parentheses with another number, and then that whole quantity is being squared. So right away I can find my vertex. It's the opposite of whatever's next to the x. So instead of positive 2, what's it going to be? Negative 2. Good. And then same sign as out here. Negative 3. So I can graph that. Where's my axis of symmetry going to be? Good. X equals negative 2. So it is the vertical line through my vertex. Is this going to open up or down? Up. Good. And remember, A in this case is in front of the parentheses. So A here is just positive 1. So it is going to open up. Now what? Good. Make an XY chart. What do we want to plug in? 0. Good. So I'd have in parentheses 0 plus 2. Then you're going to square it. Then you're going to subtract 3. So what's 0 plus 2?
2.
What's 2 squared?
4.
What's 4 minus 3? 1. Good. So I have the point 0, 1. Which means I also have what point? Negative 4, 1. Great. You guys think that's enough? Sure. We're getting there. I'd be happy with that. I don't like that side. It's not really smooth enough. There we go. All right. Most students like vertex form a little more than standard form. You can see why, right? It goes a little quicker. Any questions? All right, here's number 5. So again, we can go right into the vertex. What's my vertex going to be? Negative 1 or positive 1? Positive 1. Remember, it's always the opposite of this. It's what they're subtracting from x. So it's positive 1. And then this one you don't have to worry about the sign. It just stays the same. So my vertex is at 1, 2. And my axis of symmetry is going to go through. And it's a vertical line, so it's an x equals. So there is my vertex. And there is my axis of symmetry. What's A here? Negative 1. So should this open up or down? Down. Great. Any ideas what we want to plug in? 0. Wonderful. So I'd have negative 0 minus 1 squared plus 2. Now be careful with order of operations here. Because I do 0 minus 1. What's 0 minus 1? Negative 1. Then you square it. What's negative 1 squared? 1. But you still have this negative out front. So it's negative 1 plus 2, which is 1. So I have the point 0, 1. I also have the point 2, 1. Do you think that's enough? I don't think so. Let's plug something else in. 3, yeah. I like that you said 3 because we were on this side, but people don't really like plugging in negative numbers. So now let's go over to this side. So we can plug 3 in. So I still have the negative, and then 3 minus 1. Then we square it, we add 2. So do parentheses first. 3 minus 1 is 2. 2 squared is 4. So I now have negative 4 plus 2, which is negative 2. So I have 3 negative 2. Where would the other point be? Yeah, negative 1, negative 2. Great. I definitely think we have enough now. There we go. What are your questions on this? I'm going to actually skip this one. Don't write it down. Sorry. I want to get to the third form and make sure we have enough time to do a couple examples. So this is the third form you'll see. It's intercept form. So again, you have your A in front. You have 2 sets of parentheses. X minus P, X minus Q. This is a form you actually probably saw a lot in Algebra 1. People call this factored form as well. So you find the intercepts by setting each set of parentheses equal to 0. So if it's x minus p and you solve for 0, your intercept would be at p. X minus q, you solve for 0, your intercept is at q. And then the vertex is going to be right in between those. So we could find the average of your x-intercepts. That's the x value of the vertex. And then you plug it in. Here you will only have 3 points. Even if they're kind of close in a cluster, that's fine. You don't need to worry about an XY chart on this one. 3 points is going to be good. Do you guys have any questions as you're going through this? Anyone still writing? Oh, I see a couple people. All right, a couple more seconds. Again, the book is not very descriptive on the different ways to graph, so I would definitely make sure that you get most of this information down, if not all of it. All right, let's go ahead and look at an example. So here's our first one. Now, I told you guys you could just use P and Q to find the x-intercepts. That doesn't always work. Sometimes there's a coefficient in front of the x that's going to kind of mess things up. So I'm actually going to do it a little differently than the last slide. I'm going to set each of these equal to 0 to find the x-intercepts. And you might remember why this works from Algebra 1. Remember, to find the x-intercept, you make x equal to 0. So if this was 0 and you're multiplying two things together that equals 0, either this is 0 or this one's 0. So we can set the first quantity equal to 0 and the second quantity equal to 0. That'll give us our x-intercepts. So I'm going to subtract 3 from both sides. So one of my x-intercepts is negative 3. I'm going to add 5 to both sides, so one of my x-intercepts is 5, and then I can graph those. So I have a point at negative 3, I have a point at positive 5, now since these are symmetric, my axis of symmetry and my vertex are going to be right in between these points. So you could kind of just count and look at it to see where the middle is, or you can find the average of these two numbers. So to find the average, we just add them together. Divide by 2. So my axis of symmetry is going to be at 1. So x equals 1. And then my vertex has an x value of 1. How do you think I can find the y value of the vertex, though? Plug it in. Good. So y equals, instead of x, I'm now going to use a 1 and a 1. So the y value is negative 16. We might be a little off on this one, but that's all right. Actually, I'm going to count by 2s. And I'll still be a little off, but it'll be down here. And then I'm going to make a little note on my y-axis that I counted by 2s, just so I remember as I'm going through. Oh, I put it at 0.16. Where should it really be? 1.16. What was I thinking? So it's actually right here. That's why my graph looked kind of off. There we go. All right, what are your questions on this? All right, let's look at one more. In intercept form, and then you have a little time to do your homework. Not too much time, but remember this homework is over 2 days. So you can work on it tonight and finish it up tomorrow. So this is definitely an intercept form, and I can tell because I have 2 sets of parentheses with x's in them. How do I find my x-intercepts? Yeah, set the parentheses equal to 0. So I'll have x minus 1 equals 0. I'll have x plus 3 equals 0. So I'm going to have an x-intercept at 1 and an x-intercept at negative 3. All right, now this is the part on intercept form where students kind of forget what to do. What do I do here? Yeah, find the axis of symmetry, which is the point right in between them. So what is going to be right in between those? Negative 1. Good. If you can't tell just by looking at the graph, find the average of those two x values. That would give me negative 2 over 2, which is negative 1. So my axis of symmetry is that x equals negative 1, and my vertex has the x value of negative 1. How do you find the y? Plug it back in. Good. So I have the negative, and then I'm just replacing every x with a negative 1. So I have negative 2 times 2, which would give me what? 4. Good. So my vertex is at negative 1, 4. And then you can always double check, should this be opening up or down by looking at the equation? It should be opening down. This is A right here. A is negative 1, so it should definitely be opening down. Great. And again, in intercept form, you will only have 3 points. You'll have your 2 x-intercepts, and then you'll have your vertex. So we're good to go. Any questions? No, if you forgot this extra negative sign, you get a -4, but remember we have negative, and then -1 minus 1 is also negative. So it's like -1 times -2 times +2, which is +4. And then again, you can double check by looking at your A value. This should definitely be opening down. If we had a -4 as our vertex, it would be opening up, so I know there'd be some sort of mistake. Good question. Other questions? Here's your homework. Again, you have 2 nights to do this assignment. We are going to learn a little bit more about equations and rewriting equations tomorrow. So if you get any questions where it says rewrite the equation, just skip that one for now. Just work on the graphs. Any questions?